flip to the second page to fill in our unit circle first. Okay, so do y'all have a preference on what you fill in first around the unit circle? Do y'all want to do angles in degrees or radians, or do you like to do the ordered pairs first? Angles? Okay, so we'll start with angles. I think degrees, going around angles and degrees is probably the easiest. So if that's what you want to do first, that's not a bad idea. Okay, do y'all remember the pattern I told you it follows when you are filling in the degrees starting here at 0? Yeah, I just keep at each quadrant, I add 30, so 0 plus 30, plus 15, plus 15, plus 30. And that gets me through a quadrant. And then I do it again. I say plus 30, plus 15, plus 15, plus 30. And I do it again, plus 30, plus 15, plus 15, plus 30. Then again, plus 30, plus 15, plus 15, plus 30. And that's my full 360. Okay with degrees? Okay, now radians is a little tougher. Okay, so we know 0. Hopefully by now, you've at least got down your quadrantals, which a half circle is pi. So a full circle is 2 pi. And then halfway to pi would be pi over 2, pi halves. It's literally halfway to pi. 90 is half of 180. Okay, so that would make 270 3 pi halves, because if we count by fractions, remember it's 1/2, 2 halves. This would be 3 halves, so 3 pi halves. And then 4 pi halves, which 4 halves is 2. Okay, now from there, it might be, I've showed different ways to do this, and I don't know if y'all have used the links to resources I've given you for help with filling in and remembering the unit circle. But at this point, hopefully you realize what is the, they all have pi in them, obviously. Closest to the x-axis, all of the ones closest to the x-axis, those would be the smallest angles, wouldn't they? Out of the 3 here. So what is smallest? A 1/6, a 1/4, or a 1/3? A 1/6 is the small. If you cut something into 6 pieces, it's going to be smaller pieces than if you cut it into 4 or 3 pieces. Okay, think of an actual pizza or a pie. Okay, so those denominators in the quadrants are 6, 4, and 3. Okay, so the smallest one is a 6. So this one is pi 6. And then a 1/4. And then a 1/3. Okay, the other thing to think about if you get confused on those or mixed up on those, if you know the degrees, just divide it. We are talking, you've got to know that this is pi. The semicircle is pi. Okay, but then you can say, well, how 30 is how much of the way to 180? 180 divided by 30 is 6. That's your denominator. 180 divided by 45 is 4. 180 divided by 60 is 3. Okay, so there's different ways to help you recall those if you don't just have them memorized yet. Okay, now that means that in every quadrant, remember these reflect over. They're going to be that reference angle. So I know that the ones closest are going to be a 1/6, the middle a 1/4, and the furthest a 1/3. Now, I'll get back to the numerators in just a second, but I'm going to go ahead and fill in all my denominators. 6, 4, 3. 6, 4, 3. Okay, it's going to be something pi over each of those. Now we've talked about actually going around and counting by that fraction. Okay, or going back from pi and saying it's 1 less than a whole, or 1 more than a whole, or here, 1 less than 2 whole, okay? I don't know what's easier for y'all. In quadrant 2, just remember the numerator is 1 less than the denominator. So 1 less than 6 is 5. 1 less than 4 is 3. 1 less than 3 is 2. In this quadrant, it's 1 more than the denominator. So this is 7, 5, and 4. In this quadrant, it's 1 less than double the denominator. So double 6 is 12. 1 less than that is 11. Double this is 8. 1 less is 7. Double this is 6. 1 less is 5. That's because we're counting, we're backward, we're from 2 whole, which in 6, 2 whole is 12 sixths, and we're short 1 sixth. So that's where the 11 comes from. Okay, so whatever strategy you need to be able to fill that in to understand your angles. Okay, I think for many of you, it does help to color code or highlight your reference angles. So you're welcome to use colored pens or pencils or highlighters when you're testing to do this. So I'm going to just draw the line here at all the pi sixths. Okay, and then in a different color, I'm going to draw the line at all the pi fourths. My lines aren't all that straight, but that doesn't really matter. And then I'm going to do the same thing at all the pi thirds. So I've color coded. If I'm at any of the pink ones, I'm a pi third or a 60-degree reference angle. That's how far I am from the x-axis, etc. for the other ones as well. Okay, now filling in your coordinates, your x, y. Does anybody have a specific order or strategy they like to use for that? Sorry, I'm trying to get it to the right size so that we can see all the coordinates at once, but then it's given. I can't quite hear you. Okay, first identify what's going to be negative where. That's good. Good idea. So let me I'll do that one. I'll do the points in purple. All right. So let's go ahead and fill that in on the lines up here first, and then I'll help you do it in the ordered pairs. So remember, in quadrant 1, all trig values are positive. If you are plotting a point in quadrant 1, you know that both the x and y are positive, right? So all of the trig values will be positive. None of them will be negative. And that's because what corresponds to x and y? Trig-wise, what trig functions correspond to x? And then sine for y? We can actually flip back over to that front page. I think there was right here, it says, answer these questions about the unit circle. X, y corresponds to what trig values? That's cosine of theta, comma, sine of theta. And remember, that's alphabetical order of our 3 main trig functions, cosine and then sine. Just like x comes before y. Okay? So that's why, since when we plot a point, x and y are both positive, sine and cosine will both be positive. Okay? Tangent will then also be positive because it's y divided by x, right? And a positive divided by positive is still positive. Now in quadrant 2, if I were to plot a point, I would go left and then up. So the x's should be negative and the y's should be positive. The y's, you said, are sine. So the positive trig values are just sine. That means cosine is the x, which is negative. So if I do a positive divided by a negative, I get a negative for tangent as well. You can write out the reciprocal ones if you want. Just remember that they stick with their reciprocal. So if sine is positive, cosecant is positive. In quadrant 3, if I plot a point, I'm going left and down. So both are negative. So that's cosine and sine are both negative. But if I do a negative divided by a negative, I get a. So tangent is positive. And then in quadrant 4, if I plot a point, I go right and down. So that means x is positive, that's cosine. Y is negative, that's sine. And if I divide a negative by a positive, I get a negative. So tangent is also negative. So far, so good? So actually writing the negatives on the ordered pairs to start is a great idea. So in this quadrant, since I'm here in quadrant 4, all of the y values should be negative. So I'm going to go ahead and put a negative in front of all the y values. In this quadrant, both x and y are going to be negative. In this quadrant 2, just the x will be negative. There will be no negatives in quadrant 1. Now, what about the quadrantals? Those points, hopefully you know, if I'm at 0, 0, coming back up here, answer these questions about the unit circle. The center is at 0, 0. Okay. What is the radius of the unit circle? 1. So if that's the case, if this center is at 0, 0, and this distance is 1, what is this point? Okay, what's this one at the top? Left and bottom. Good. All right, now all of the other coordinates at the 30, 60, and 30, 45, and 60-degree reference angles. All of them are over 2. Every single value is over 2. It's either square root of 3 over 2, 1 over 2, or square root of 2 over 2, right? So go ahead and put everything's over 2. Don't miss that, because that one is the same for all of those. And all of those special angles, everything is over 2. Now, at the different reference angles in quadrant 1, hopefully you remember what the 3 options are. It's square root of 3 over 2, 1/2, so 1 over 2, or square root of 2 over 2. Okay. The one where it's square root of 2 over 2, that's where x and y are the same, right? They're both square root of 2 over 2. That is because it's an isosceles triangle created, a 45, 45, 90. Okay, so if I were to create a triangle to that point, I would go over and up equal distances. So at 45, that's the one where it's square root of 2 over 2. And it's the same for x and y. Okay, and you could fill that in every quadrant. We already got the negatives filled in where they're supposed to be. So at all the 45-degree angles, at all of these that have a denominator of 4 for the radian measure, it's root 2 over 2, root 2 over 2. Only what's positive or negative changes when you change quadrant. Now the 30 and the 60, those are the ones most commonly mixed up, because it's root 3 over 2 and 1/2, and then the other one's reversed, right? The memory trick that I've told y'all to remember which one goes at 30 and which one goes at 60 is 30 starts with 3. So it's square root of 3 over 2 first, and then the 1/2. 30 starts with 3. The ordered pair starts with 3. 60 is the one where it's reversed. You have the 1/2 and then the root 3 over 2. So then we can mirror that over. All of these that I highlighted green are going to be square root of 3 over 2, 1/2. And then all of these that I highlighted in pink, those are all your pi thirds or 60 reference angles. Those are all going to have the 1/2 first, and then the √3/2. Feel okay about the ordered pairs? Remember, that's all of your sine and cosine values around the unit circle. Sine is all of the y's, cosine is all of the x's. Okay, so the only thing out there then is tangent. Because tangent is sine divided by cosine. So if you don't memorize tangent, as long as you know it's y over x or sine over cosine, you can calculate it. But if you memorized it, it will just save you some time. Okay, so when we're filling in our tangent values around the outside, okay, y divided by x. So when sine is 0, tangent is 0. Because 0 divided by anything is 0. So tangent is 0 when you're on the x-axis. Okay, but if you're on the y-axis, it becomes 1 over 0. You cannot divide by 0. So if you're on the y-axis, tangent is undefined. And then within the quadrants, anything divided by itself is 1. So at 45 degrees, when x and y are equal numbers, tangent is 1. So at every 45, at every one that I highlighted in blue, tangent is 1. But now I have to pay attention to my positive or negative. So I'm going to go ahead and fill in which quadrants should tangent be negative. So what did we say here in quadrant 2? Tangent was negative, right? So I'm going to go ahead and put a negative in front of all the tangent values. In quadrant 3, we said it was positive. And then in quadrant 4, we said it was negative. So I'm going to go ahead and put a negative in front of all the tangent values there. Remember, your memory trick for what's positive where, all students take calculus. So this is what's positive. All of them are positive, and here tangent is positive. So it must be negative in these two. Good? All right, so I'm going to go ahead and fill in the ones then at all of the 45-degree reference. So that one's -1. This one's +1. That one's -1. Okay, now at the 30 and the 60, again, this is a common one to mix up because it's very similar. It's square root of 3 and square root of 3 over 3. It's a reciprocal value. Okay, the memory trick for remembering which one goes where is, again, not only does 30 start with 3, 30 has the extra 3. So the over 3 goes at the 30, and then at 60, it's just √3. There's no denominator. So then I can reflect that over into every quadrant. The better you understand the unit circle, the easier the rest of the test will be. And not just this test. We're going to continue with trig when we come back from the break. Any questions about the unit circle? Okay, so now we can answer lots of questions about it. I'll zoom in now on the front side. All right, so first of all, this first part says spiral review. This is just kind of reviewing. This is stuff we initially learned in Unit 2, but we still need to know it. Okay, so which trig values are positive in each quadrant? We actually just went over that on the unit circle. We said quadrant 1 was all of them. Remember, all students take calculus for quadrant 1, 2, 3, 4. So that's all of them. That's sine, tangent, and cosine. Now, I'm going to go ahead here and list the reciprocals as well. So, because they're asking which ones are positive. So if sine is positive, cosecant is. If tangent is, cotangent is. And if cosine is, secant is. That's the ones that are positive in each of those quadrants. All right, and then over here it says, in which quadrant is the terminal side of theta if theta is 117 degrees or if theta is negative 9 pi fourths? Okay, so again, this is just knowing terminal side means where does it stop? Where is the end of the angle? Where does it stop? Okay, so if it helps you to sketch it, or you can look at your unit circle and say, well, where's 117 degrees? Okay, well, here's 120, here's 90. It'd be between those, wouldn't it? So what quadrant is that? Where's 117 degrees going to be? Quadrant 2. That's it. Okay, and then this one says negative 9 pi fourths. Now, I can't see that one directly on my unit circle, but let's take a look. It's in fourths. 9 pi fourths. Okay, the fourths are the ones that I highlighted in blue. Now, this one's going in the negative direction. 9 fourths. 9 fourths is more than 2 whole, isn't it? 4 goes into 9 twice. So that's actually one of the strategies you can use when you have a bigger denominator, when it's more than double the numerator is more than double the denominator, you know it's past a full circle. So if you want to change it to a mixed number, 4 would go into 9 twice, and you'd be left with 1/4. If it helps you to visualize it around your unit circle by doing that, go for it. So this is negative 2 and 1/4 pi. So the negative 2 pi, so in the negative direction, I'm going clockwise, 2 pi puts me back to the positive side of the x-axis, and then I go 1 pi fourth more in the negative direction. So I go to the first blue line. So what quadrant does that put me in? Good. If you need a visual of that. So I went around, and then here I stopped in quadrant 4 like that. Okay. All right, 7 wants us to actually sketch the angle and give the reference angle. So again, fourths. This is bigger than double, 11. If I want it, does that help some of you to make it a mixed number? So if you want to do that, how many times does 4 go into 11? And how many are you left with after that? So you're going 2 and 3/4. Now this is positive. So in the positive direction, the 2 is a full circle. And then where would 3 pi fourths be? That's on your unit circle. Here, right? Then it's halfway through quadrant 2. Okay. And then the reference angle is how far from the x-axis you are. So the reference angle is this angle here. But if your radian measure is reduced, you can immediately see your reference angle. You don't have to do anything. It's pi fourths. As long as that's a reduced fraction, that's your reference angle. So the reference angle is pi fourths. We are pi fourths away from the x-axis when we're at 3 pi fourths. All right, in degrees, negative 515. So I'm going in the negative direction this time. Okay, so think in terms of a full circle. So a full circle would be how many degrees? 360. So you say, okay, how much more do I have to go? So I do 515 minus 360, right? Y'all agree? So that leaves me with 155 degrees to go. So you can look at your unit circle, but because this is in the negative direction, you still have to be real careful. So in the negative direction, this would be 90. And then this would be 180. And I'm only going 155. So wouldn't it be between 90 and 180 somewhere in the negative direction? So it's going to be somewhere over here. Doesn't have to be perfect. Just get it in the right quadrant. Okay. And then I want the reference angle. Well, how far past 360 did you say we went? This piece just right here was 155. And then if this is 180, I really just need the difference between 180 and 155, don't I? Which, what does that come out to? Just count from 55 to 80. How much further do you go? Yeah. So the reference angle there's 25 degrees. Now, that angle given was negative. My reference angle is not, because reference angles are never negative. They're terminal side from the x-axis. It doesn't have a direction. All right, now converting. If the denominator of a radian angle is one that you know from the unit circle, then you can do a quick conversion and just say, okay, I know that pi 6 is 30 degrees. So then I just have to do 17 times 30. And you'll have a basic calculator. You don't have to do that in your head or by hand. That comes out to 510. Now, if you don't know or realize that you can do that quick conversion, the actual conversion method for radians to degrees, oops, 17, is to take your radian measure and multiply by 180 over pi. That's the conversion, 180 over pi. Or if you're going from degrees to radians, it's pi over 180. It's where, however, it's in the order so that you can get your measure to reduce. So the pi's reduce, the radians cancel, and you're left with just the degrees. Okay, so if you do it this way, that's fine. You would have to do 17 times 180 divided by 6. Okay, and that's going to get you the same 510. It's just a little bit longer process. Okay, now, if you're going from degree to radian, hopefully you recognize degrees that come from your unit circle. And you can just go look at your unit circle. 300 degrees is equivalent to what? 5 pi thirds. Now this is negative 300, so it needs to be negative 5 pi thirds. Now, if you don't realize that that's a value off your unit circle, do your actual conversion, which is to multiply by pi over 180. Because that way the degree units cancel and you're left in radians. But then you have 300 over 180, and then you still have the pi there as well. And you just have to reduce 300 over 180. Well, the zeros will reduce, then it's 30 over 18. 6 goes into 35 and into 18 3 times. And then that was a negative times a positive, so this is still negative. So you get the same answer doing the conversion, but if you're able to know your values, it makes it a little quicker. Good? All right. Next part. Find one positive and one negative coterminal angle. So I'm going to sketch pictures for these. Coterminal means starts in the same place, ends in the same place. So pi thirds is right here. That's a picture of the angle that we're given. We need one in the positive direction and one in the negative direction that are not the same. So when you go in the opposite direction of the original, you can just go straight there and stop. Okay, and then we will be 1 pi third short of a full circle, right? In the negative direction. So that would be negative 5 pi thirds. Now in the positive direction, I can't just go there and stop because that is the original. That's not any different. So I have to pass it and loop back to it. So I'm doing the original angle plus a full circle. Okay, so a full circle in thirds is 6 thirds plus the 1. So that is 7 pi thirds. So that's a negative and a positive coterminal angle. Now, your other option is to do it just algebraically, physically, write down the fractions and add them or subtract them. We know that coterminal angles just means to add or subtract what to your angle? A full circle, 360 if you're in degrees, or 2 pi if you're in radians. So for 12, let's do it that way without a picture. Let's just take our given angle and we're going to add a full circle. Now, I can't just add 2 pi because this one's a fraction, right? To add fractions, you have to have a common denominator. So I would have to change this. Instead of 2 pi, I'd want it in halves. So I'd have to change it to 4 pi halves, right? That's the same thing as 2 pi. Is 4 pi halves. Now I can add those. And I end up, so I have negative 3 plus 4. That's positive, isn't it? So this is going to be my positive, and that's a positive 1. I don't have to write an understood 1 there. But that would be my positive coterminal. Okay, now in the negative direction, I would take my original angle and I would subtract a full circle, which we said is 4 pi halves. So I end up with negative 3 minus 4, which is negative 7 pi halves. Now, if you added a full circle and your value was still negative, that's a negative coterminal angle. You would just add a full circle again until you got to positive. Okay, so it depends on the size of the angle if you'll have to add the full circle multiple times to get an opposite sine angle, or if just one time will work. Because I just rewrote 2 pi in terms of the fraction I'm trying to add or subtract from, which was halves, because to add or subtract fractions, I have to have the common denominator. So 4 over 2 is 2, right? So I just rewrote it so that I had a common denominator. So over here, if I had done that, I would be trying to add to thirds. What would I add or subtract to this? What would a full circle be in thirds? 6, it's just double the denominator. So 6 pi thirds would have been what I added. So 1 pi third plus 6 pi thirds, that's where 7 pi thirds comes from. Or 1 pi thirds minus 6 pi thirds, 1 minus 6, that's where the negative 5 comes from. So we did this one with a picture. We did this one just using the math. It's up to you, your preference. Okay, so with degrees, it's probably easiest just to do the math. I think with radians, it helps to have a picture for some people. But here, I'm just going to add or subtract 360. So I've got 122 plus 360. and 122 minus 360. So what is my positive? When I add those, what do I get? So 482 degrees is a positive coterminal angle. And when I subtract, I get negative 238. So that is a negative coterminal angle. I'm going to do the same thing here. I'm starting with a negative though. So when I add 360, I am actually still negative, right? Negative 40. So that's a negative coterminal. Even though I added 360, my answer is negative. So it is a negative coterminal angle. So I'm going to take that and add another 360 until I get to a positive. So then when I add another 360, that gives me what? Yeah, it's like doing 360 minus 40, if you want to think of it that way. But I get 320 as my positive coterminal angle. I could have done negative 400 minus 360 and gotten negative 760. That's also a negative coterminal angle. That's also a correct answer for a negative. There's infinitely many correct answers for coterminal angles because you can just keep adding or subtracting 360 and get more and more and more answers. Okay. All right. Really quickly, just the ratios. What are the ratios? And I put or here. If you prefer OA and H, that's great. If you can do X, Y, R, that's even better. But you have to know what the ratios are, and you have to know which one is the reciprocal. So sine is O over H or Y over R. What's sine's reciprocal? Which function is the reciprocal of sine? Cosecant. And so its ratio would be H over O or R over Y. Cosine, A over H or X over R. What's its reciprocal? Secant. So its ratio would be H over A or R over X. Tangent's ratio is O over A or Y over X. And what's its reciprocal function? Cotangent. So cotangent's ratio would be A over O or X over Y. You have to know your ratios. All right, I'm gonna stop this video here. I'll post another video going over these types of questions. These are similar to what was on your quiz, this past quiz that we took on Friday. And on that practice paper I gave you, and you had a Delta Math with lots of practice like this. Okay, so there'll be a second video going over that if you have questions on that.